Artificial intelligence can feel like absolute magic. But really, under the hood, there's a surprisingly simple and powerful method it uses to solve problems. So today, we're going to pull back the curtain and break down exactly how an AI thinks its way from a problem to a solution, using a process called search.
Here's what we've got on tap. We'll kick things off with the core method AI uses. Then we'll walk through a real-world example, a road trip. After that, we'll get into the nitty-gritty, the 5 specific rules an AI follows. Then we'll see how this whole idea applies to way more than just maps. And finally, we'll uncover the real secret to AI problem solving. All right, let's jump right in. So when you boil it all down, AI problem solving is really all about finding a path. I mean, think about it. Whether it's getting you through city traffic or figuring out the winning move in a chess game, the basic challenge is exactly the same. Find the right sequence of steps to get to the goal. I mean, really think about it for a second. When you pop an address into your phone, it doesn't just give you a way to get there. It finds the best way. It's juggling traffic, distance, road closures, all that stuff. How on earth does it sift through a crazy number of possible routes so fast? Well, the answer is a very specific process called search. Now, when we say search in AI, we're not talking about typing something into a search engine. No. It's a much more formal process. It's all about systematically, methodically exploring every possible alternative, every turn, every potential path, to find that perfect sequence of actions that takes you from where you are to where you want to be. Okay, to make this all really click, we're going to use a classic example from the world of AI. Let's imagine we're on a holiday road trip. We're in a foreign country, and we've got to drive across it to catch a flight tomorrow. This isn't just some random scenario. It's the perfect kind of problem that an AI is designed to solve.
All right, here is our map. So we're starting out in the city of Arad, way over on the left. And our goal, get to Bucharest on the right to catch that flight. Now, a human would just glance at the map and kind of eyeball it right, make some educated guesses. But an AI needs a much more structured way to tackle this. And that structured approach, it has a name. It's called problem formulation. See, an AI can't solve a problem it doesn't fundamentally understand. So before it does a single thing, it translates our little road trip problem into its own language by defining 5 very specific rules.
And these are the 5 rules. It needs to know its starting point, what moves it's allowed to make, what happens after each move, how to know when it's finished, and how to tell a good solution from a bad one. Let's break these down one by one with our road trip. First up, the initial state. And you know what? This one's the easiest. It's just, where are we starting? For our problem, the AI just logs the initial state as being in the city of Arad. That's it. It's basically the "you are here" pin on the map. Okay, next, the AI needs to know its options. From where it is right now, what can it do? So if we're in Arad, we can look at the map and see there are 3 roads leading out. So for the AI, the available actions are go to Sibiu, go to Timisoara, or go to Zerend. Simple. Rule number 3 is the transition model. You can think of this as the if this, then that rule. It's cause and effect. It just tells the AI what happens when it takes an action. So if your state is in Arad and you take the action, go to Zerend, the result is a brand new state. You're now in Zerend. This is literally how the AI moves across its mental map.
So how does the AI know when it's done? When has it actually won the game? That's the goal test. Every time it arrives in a new city, it asks a very simple yes or no question. For our trip, that question is my current location in Bucharest? If the answer is no, it just keeps on searching. If it's yes, boom, problem solved.
And finally, rule number 5, the path cost. Because look, any route that gets us to Bucharest is a solution, but not all solutions are created equal, right? The path cost is how we measure the quality of a solution. On this map, those little numbers are the distances. The AI just adds them up for any route it finds to get the total kilometers. The best solution, of course, is the one with the lowest total cost.
Okay, so we've just broken down a simple road trip into 5 rules. Pretty neat. But here's where it gets really cool. This whole framework, it's not just for finding your way around Romania. It is a universal blueprint for problem solving.
Just look at this. On the left, our road trip. On the right, one of those classic 8 puzzles where you slide the tiles around. To us, these look like totally different activities. One's driving, one's a game. But to an AI, once you frame them with those 5 rules, they are structurally, fundamentally, the exact same problem. And that right there, that's the power of abstraction in AI.
And this table just lays it all out perfectly.
Check out the columns: our Romania trip, the 8 puzzle, and even a little robot vacuum cleaner. Now look at the rows for each of our 5 rules. The details are different, sure. An action might be go to a city or move the blank tile up. But the underlying 5-part structure, it's identical. For an AI, solving any of these is just a matter of plugging them into the same system.
And that brings us to the single most important takeaway from all of this. The real intelligence, the real magic, isn't just in the searching part. It's in the setup. It's in the ability to formulate the problem the right way in the first place.
So here's the bottom line. That 5-part framework we've been talking about, it's like a universal translator. It can take a messy, real-world challenge, a road trip, a puzzle, a dirty floor, and turn it into a clean, logical map. A map that the AI can then navigate, step by step, to find the absolute best path to the goal.
And that leaves us with a pretty big question to chew on, doesn't it? If this method is so powerful, so universal, what are its limits? What kind of problems out there can't be neatly packaged into a starting point, a set of actions, and a clear goal? Finding the answer to that, well, that's where the next chapter of AI really begins.